In lesson 13.4, you're going to be learning about the law of sines, so you can write down your title and your essential question. And then down below here we have the area of a triangle. So anything that is outlined in that dotted box, you'll want to copy that down. So you'll want to hit pause. And then we have the law of sines. Again, anything that is in a dotted box, you want to copy that down. And we can use the law of sines to help us solve triangles. Now, when we do this, though, you always want to make sure that you are starting with the biggest angle. And then a couple of cases that we might run into. So again, everything that is in a dotted box you'll want to write down. If angle A over here, if that's an acute angle, it could end up being that side A is too short, so there's no solution. It could end up that it comes down and it meets exactly on the line. That would be one solution, just a right triangle. But it could have two solutions where it could swing in and touch right here, or it could swing out and touch right there. So that would be two solutions. But if it's too big, if it's longer than side B here, it can't swing in. It could only swing out. Then it's one solution. So you're going to have to look at this and decide if it's no solution, one solution, or two solution. Now, if A is obtuse, it's a little easier. Either it works or it doesn't. As long as A is less than or equal to B, you're going to get no solution. But as long as A is greater than B, you will get a solution out here. And then you'll solve them. And then remember that you can find the height of, which is B sine of A. And here's some study tips for you to look over. And start by copying down that triangle. So first thing we need to do is find the area. And if we go back to our area slides, we've got the formula right here. It's half B, C, and A, or half A, C, and B. So whatever angle we use the two sides next to it. So if we're using this angle, we use the two sides next to it. So again, wrong page. Wrong page again. It's half, the two sides, and then the sine. So half 6 times 3 times the sine of the angle. And you can just type that into your calculator. Make sure when you're typing it in that you are in degrees, because it's given as 25 degrees, not 25 radians, which you come out to be 3.8. All right, solve this triangle. That means find all of the missing parts. So this is going to be using the law of sines. Now the laws of sines is set up. Sine of an angle A is related to side A. Sine of angle B is related to side B. Sine of angle C is related to side C. And we can use any two of these ratios to solve this. So let's look through this. I see here that we have B and 9. Those two are related. So we're definitely going to want to use this one. So we'd say sine of 53 over 9 equals, let's try C. Well, that's going to be this one right here and that one right there. They're always opposite of each other. So sine of 100 over C. So to solve this, you're going to cross multiply and divide. So 9 times the sine of 100, and then divide by the sine of 53. So if we take out our calculators, you could do 9 times the sine of 100, and then you can divide it right away by the sine of 53. And our answer is 11.1 if we round it. So C equals 11.1. And now A. We should always go back to the original one, so we should do sine of 53 over 9 equals, what do we have for A? We don't know the angle, and, oh, but we do know the angle. We can figure that one out. And then we don't know side A. So to help us find angle A, we're going to have to add those two angles together, 100 plus 53, and then subtract that from 180. And so now we know that angle A is 27. So then we can set up a ratio and say the sine of 27 degrees over A equals sine of 50 over 9. Cross multiply. Those two can be multiplied together. So we would type in sine, whoops, I missed. Sine of 27 times 9 divided by sine of 53. And we get 5.1. So everything that we needed to find, A was 27, 5.1 was lowercase a, lowercase c is 11.1. Okay, now we're on to the question where we have to know if it's one solution, two solutions, or no solutions. So let's start by drawing out this triangle. Now when we draw out our triangles, the angle is always opposite of the side. So if we start with our angle, let's make 110 degrees. That's Q. So first of all, we know we're working with the acute side of this page over here. So we're working on this side. We have to decide, is A less than B or is A greater than B? So if that was our angle, our side, which is over here, is 11. And the other side, which would be over here, is going to be 8. So since it's greater, that means we can connect it down and make our triangle. This is going to be N over here. We looked back to see what's our other letter, P. So now we need to solve this. So we can say sine of 110 is related to its side, which was 11, in the same way that we know side 8 and n's related to that. So sine of n is related to 8. Okay, here we're going to cross multiply and divide. So sine of 110 times 8. And then divide that by 11. Now be careful here because this says the sine of n equals that decimal answer, 0.68. So how do you find what n equals? You do the inverse. And when you do that, you go second sine, second answer, and hit enter. So 43.1 is the angle. So that's one of our answers. Now we can find P pretty easily. 110 plus 43.1 and subtract that from 180. So now we can say P equals 26.9. We've got two of them. We have to find the third side. And the only way to find that is, again, to do the law of sines. So go back to the ones we know. Sine of 110 over 11 equals, we have to find lowercase p here. So sine of angle P, 26.9, over lowercase p. Cross multiply and divide. So 11 times the sine 26.9 divided by the sine of 110. 5.3. So lowercase p equals 5.3. And there we have solved that triangle. Okay, let's try another one. So this time we have an acute angle, meaning that we're going to have to go to the left side of this. So where A is acute, we need to decide how it compares to H. And again, we find H by doing B sine of A. B is over here, A is over there. So we start by drawing this out. Angle E is 52. E is going to hang down over here at 5. F is going to be the other number. We always put that there. So how does this compare to the height? Well, we do 9 sine of 52, and that's going to equal the height. And the height is this dotted line right there. So type that in, 9 sine of 52, and you get 7.09. So if this little line right there is 7.09, and this side's only 5, that means it's going to hang down and it's never going to touch it. So that's no solution. Alright, that's where I'm going to stop part 1 of the video, and then you can come back and watch part 2 as well.